continuity and discontinuity. Okay, continuity is the next normal, makes sense step after limits. We've already kind of reviewed all the different kinds of limits. Now we're moving on to continuity. And here's what it is defined to be. A function is continuous at x equals c if the following three criteria are met. And this is the formal definition of continuity. You may have been told in pre-cal that continuous just means that you can draw it without lifting your pencil. That's the simple definition. This is the mathematical definition. And it makes sense when you talk about limits. So, criteria number one, f of c has to equal some number we'll call L1. In other words, there is a y value. There's a dot. Okay? So in simple English, this is there is a y value. There's a y value at L1. Number two, the limit as x approaches c from the left of the function is L2, and the limit as x approaches c from the right of the function is L3. So basically it says the function has a left-hand limit and it has a right-hand limit and it has a dot. It has to have all three of those. And the final criteria is what ties it all together. L1 has to equal L2, which has to equal L3. They all have to land in the same place. The left-hand limit has to go to the same place as the right-hand limit, and it has to land where the dot is. That's what makes it continuous. Okay? Now, if a function doesn't do that, if a function is not continuous at x equals c, it is said to be discontinuous. We don't say not continuous, we say discontinuous. And there are three types of discontinuity that you need to be familiar with. Dot, dot. So there's three criteria to be continuous, and then there's three types of discontinuity. Number one, it's called point discontinuity. And it looks like this, where here's L2, here's L3, the left and right hand limit are both approaching the same place, but L1 is down here, or up above it. The point's not in the same place. That's point discontinuity. Does that make sense? Two sides meet, but not where it's supposed to.
Why would it be L1 and L2 be continuous?
Say that one more time.
Does it matter which L is the discontinuity?
No, does not matter. Number two, this is called jump discontinuity. This is a situation where you have maybe this. L1, remember, is the dot. L2 is the left limit. L3 is the right limit. So they're not all meeting up. L1 and L3 are in the same place, no problem. L2 is off in another world. So this is L2 and that's L3 right there. And then finally, we have infinite discontinuity. And that's a situation where L2 and L3 are both going to say infinity, But there's no dot at infinity, so there's no way it can be continuous. So we have point, jump, and infinite discontinuity. Okay? Now the last thing I want to say about this is that point discontinuity is what we call removable. Semicolon. That means with one change, the function could be made continuous. So if we made one little change on point discontinuity, if we moved L1 up and put it in the hole, it would be continuous. Jump discontinuity is not that easy because a limit involves a whole bunch of points, not just one point. I can't fix that broken graph. There's no way I can fix that. I can only fix the first one. Does that make sense? I can move a dot. All right. I would like to do an example of what the homework's going to look like real quickly. And then we'll be done. Example. Let F have the graph shown here. Dot, dot. So. I'm going to make it simpler. Okay, can you tell me the limit as x approaches 0 from the left? It is 0. Part B, the limit as x approaches 0 from the right. 2. Are we all together? What is f of 0? 0. Okay. Now, the one we just did was L1 because that's the dot. The left limit is L2. The right limit is L3. Are they all the same? No. So, is F continuous at 0? And the answer is no. What kind of discontinuity does it have? It has jump discontinuity. That's the kind of questions you're going to be asked on the homework tonight. Okay? Let me show it to you. And I'll hand this out in about 2 seconds. Okay? So, here's the homework. It gives you functions instead. You're going to have to sketch them. Sketch the graph. Find the right and left hand limit as you approach 2. It's 2 every time. Find the limit as x approaches 2. In other words, if the left-hand limit is 2, okay, I didn't do that here. If I had just said, what is the limit as x approaches 0, what would it be? Does not exist because the left-hand limit doesn't equal the right-hand limit, okay? So you're... you can use calculator, yeah. Find f of 2, find the dot, and then tell me if it's discontinuous, what kind it is. Does that make sense? Okay.